Welcome, everyone. My name is Aaron Elmore. I am an associate professor of computer science at the University of Chicago and moderating today's debate on if big data is dead. It's a funeral or renaissance. So we're joined with Jordan Tigani, who is the co-founder and CEO of MotherDuck, and Aditya Parameswaran, who is a co-founder of Ponder and associate professor at the University of California, Berkeley. So we're going to start off with some brief introductions from the folks. They're going to tell a little bit about their background, kind of what big data means to them, and they're going to summarize the respective blog posts that led to this debate. So since Jordan had the post that started this, we'll have Jordan go ahead and kick us off.
Thanks, Aaron. Very excited to be here with you, Aditya, as well. I'm Jordan Tigani. I've worked for a long time on Google BigQuery, kind of at the outside of the big data era, and I think we capitalized on sort of a lot of the momentum behind that. I started MotherDuck in large part because we saw that the people that were using BigQuery, many of them didn't actually have big data, and that everybody's sort of focusing on these giant data sizes that may not be kind of what everybody has. Kind of just to summarize the blog post, really like most people don't actually have that much data. Since I wrote the post, a lot of people have been sort of coming out of the woodwork saying like, this was incredibly validating because as a data engineer or data scientist or data analyst, like I've sort of felt almost like I've had this like inferiority complex because like I wasn't using billions or trillions of rows of data. And, I would go to these conferences and where they talk about the Netflix architecture and I'd come home and be like, yeah, I'd be super excited. And then I'm like, but what am I going to do? Run this all in a one node Spark cluster. And so, for a bunch of reasons that people don't actually have big data. Kind of there was an interesting part of that, which is that, like separation of storage and compute really split big data. So which used to be sort of one term into sort of big storage and big compute. And big storage is certainly a thing that people definitely like accumulate a lot of data over time. But I think big compute is really sort of what we're talking about, that like actually for the most part, you don't need to have giant amounts of compute. And when you kind of have a modern data system that has, good metadata management, for example, you end up like, even if the data size is very large, you end up only reading a smaller proportion of that. Like, and one of the things we noticed on BigQuery was that 90% of queries were sub 100 megabytes. And, really because people always talk about what their data warehouse size is, which is sort of the total data storage, but that's almost irrelevant for actually what they need to do. It's really the workload sizes, and the workload sizes tend to be much, much smaller, particularly when you're dealing with sort of columnar storage and, properly partitioned data. One of the reasons that those work so well is that there's a real recency bias in terms of how data is accessed. Sort of the vast majority of the data that's accessed is really from the last day, last 7 days, the last 14 days, maybe the last 30 days. And then really after that, it really, really gets quiet. And, one of the things that's really kind of pushing this is Moore's law. So when big data started being talked about in the early 2000s, a single machine might only have like a core, one core and a couple gigs of RAM. Now you can get pretty basic instances for not that much money that are 2 orders of magnitude more than that. And Moore's law has not been slowing down. So really, since in those 20 years, the amount of hardware on a single chip has gone up by 3 orders of magnitude. So like the threshold for what has been big data has been changing and is going to continue to change. So if it's something that's like 5, maybe you need 10 servers now, in 5 years, chances are you'll be able to do that on one. And then just the last part is, data being a liability that, often people don't know what data they have. So they're like, well, I need big data because I have all this stuff sitting around. And better inventorying, better data management processes can avoid spending, because the thing is, if your data sizes are increasing exponentially, your costs are also increasing exponentially, because the cost of storage, at least on public cloud object stores, is not actually going down. And so the only way to prevent that is to really pare down the amount of data that you're keeping. So yeah, that's sort of the summary. Chances are, yes, there are some people that have big data and big compute needs, but for the most part, that's not what most people need, and they would likely be better off optimizing their systems and designing their systems for the usability of the data rather than the size.
Okay, great. Thanks, Jordan. All right, so let's let Aditya kind of again introduce himself, define what big data means to him, and go ahead and kind of summarize his rebuttal to Jordan's post.
Awesome. So I'm Aditya Parameswaran. I'm a co-founder at Ponder, also a professor at Berkeley. I've been part of the database research community for a while. I've kind of seen trends come and go, and big data was a trend or is a trend. And I think my humble plea to Jordan and others is, let's not kill the big data buzzword, because who knows what will emerge in its place. The reverse ETL, analytical data mesh, maybe, and let's not introduce a new buzzword. So that's my humble plea. So thanks to Jordan for writing a thought-provoking blog post, and me as an academic, I couldn't resist putting all my fingers in there and trying to tease it apart and trying to tear down the argument. So let me try to make my sort of claim. So the broad nature of my argument is that organizations have big data needs, medium data needs, and small data needs, and the key is to be able to be flexible to those organizational needs. And so we should embrace and support kind of the duck-sized workloads as well as the elephant-sized workloads, right? So let's not prefer one over the other. So responding more explicitly to some of the points that Jordan raised in his blog post and what he described just now. The first point, which is that most people don't have that much data, and I don't necessarily agree with that. But if you think about customer data, or if you think about transactional data, fine, maybe your data isn't big, but the present world is highly instrumented, highly interconnected. Even like a small, simple website tracks thousands of user actions across like hundreds of attributes, right? So very quickly it blows up. And if you look at most domains, healthcare, finance, what have you, they have this sort of operational interactions data. So it's no longer about transactions, it's about interactions, right? So why wouldn't you want to leverage all of this data for high quality, high fidelity insights or models? The next point that Jordan brought up is like the storage versus compute bit. And I think that there's a little bit more nuance there than what he mentioned, which is that even if the average workload's compute needs are small, doesn't mean that all of the workload compute needs are small. So in fact, a lot of the important workloads compute needs are not small, and you want the flexibility to be able to scale up and down depending on the workload. And simply saying, hey, I'm just going to get a beefy machine and be done with it doesn't quite work, because you're at that point, you're ending up doing the should you run your own servers versus should you use the cloud argument. And for a lot of organizations, the cloud is the right answer. The ability to flexibly scale up and down is the right answer, rather than simply like provisioning upfront and what are usually pretty expensive servers. The next point that I think Jordan brought up is most data isn't queried, right? And I think there is definitely a recency bias to data, like to querying data, and recent data is queried more. But as we're learning with ML and data science, you kind of need to look at all of the data, and looking at more data and throwing more compute is going to lead to better accuracies, right? I mean, if there's one thing that we learned from the chat GPTs of the world, is that they are revolutionizing how we do knowledge work, and they wouldn't exist if we hadn't thrown more data and compute at the problem. So, and at a much smaller scale, of course, we're not talking about those throwing massive compute and data at the problem like OpenAI might. This is at a much smaller scale, holding true in individual enterprises as well. So it's better to have the flexibility to scale up and down. And for at least a high value workload to be able to operate on as much data as possible. And then I think the final point is around kind of the single machine versus big beefy cluster. Often you'll find that a lot of the beefy machines that you might need to provision to run your workload currently is actually pretty expensive. Even with Moore's law, it's currently pretty expensive. And there are often other workloads that that won't fit in that single machine, and so you need to provision a cluster of machines. So you end up with the same cloud-sized problem, right? Like, do you provision your own expensive resources, or do you allow for flexible scaling up and down? And so I think to summarize, I mean, all organizations have small data needs, medium data needs, big data needs on a day-to-day kind of on a query-to-query basis, and we should instead be working on tools that allow you to switch between these modes, flexibly scale up and down, allow users to get insights and build models and so on, independent of data size.
Okay, great. So we can get into questions then, and then, you know, we can allow some back and forth, you know, depending on the question. But, you know, so, I kind of came up around the same time as Aditya through, as XML was decaying inside of the database community and web services were decaying, and this, big data thing. And, in my opinion, a lot of it was energized by, Google, Amazon, these promises of these kind of like large shops that could run at, web scale, right? And, part of the traditional definition that I was given for big data, or people, maybe this was just the marketing hype, was the 3 V's of big data, right? So we have velocity, meaning the data coming in, it's coming in at a really high rate. You've got the volume, which we're talking about a lot already with the scale of the data. And then variety, it's heterogeneous data. It's not always structured. It doesn't always fit into a relational data model. So, you both have talked about kind of like storage and compute, but so is it that you think some of the V's are no longer relevant? They are irrelevant today. Is it just that we have systems that address these needs, so it's not as much of a concern? And then possibly, maybe going in and then, articulating, more clearly, like how would you actually define what big data means in, 2023? So Aditya, since you were unmuted, let's start with you.
Sure. So I think that at least 2 of the 3 V's, the volume and velocity needs still exist today, right? And I think you can't get around leveraging quote unquote traditional big data tools to address them, right? And for example, if you have a fire hose of information, you absolutely need big data tools to be able to handle that. And I think that it's since you mentioned kind of the big data hype of 2010 and the NoSQL movement, I think one of the lessons of the NoSQL movement was not that, and the fact that it kind of died down, and so a lot of the popular NoSQL systems no longer are as popular or as prevalent today. I think the main lesson to be taken from that is the fact that SQL is incredibly popular. People will still love to write SQL over most other querying languages. There's kind of a staying power, as I think Mike Stonebaker called it. It's intergalactic data speak, right? Like that's what it is now. And I think pandas, the reason why Panda exists is because pandas is similar, right? Like it's like spoken by 25% of developers, and we believe that it's not going anywhere anytime soon. And so I think as kind of these systems died out, what emerged was systems that did support SQL but could operate on larger data sets. You have the Sparks of the world supporting larger data sets, and also supporting data sets without schema, right? So being able to support the variety of the other V, the heterogeneous JSON shaped data sets. And you had systems like Postgres and MySQL being able to support that. So broadly, I think the 3 V's is still incredibly relevant, and it's very hard to address them without big data systems.
Jordan?
Cool. So I'm glad you described what the 3 V's were, because when I heard that question, I'm like, Vim, Vigor, and Verve. But I guess the first one that the one that I mostly talk about when I'm talking about big data, it's volume, and how much data do you actually have, and and that's mostly what I addressed the post at. I feel like the variety is less important from a big data perspective, because nowadays even Postgres supports JSON and kind of nested queries with arrays, and that's becoming popular in all sorts of data systems. Certainly it's in DuckDB. The velocity, I think, is the one that's still quite interesting. It's like, if there are a number of places where you have these fire hoses that have massive amounts of data, and you have to figure out how are you gonna land that data. I think that there are some non big data ish solutions to that I think may be actually more interesting and more actually more scalable from a certainly a cost perspective, which kind of move the analysis, the filtering and analysis of that data out to where the data is being generated, rather than having to sort of pull it all into a single centralized location. But certainly that is kind of another interesting area of where you might still need to scale out. But that at least also is kind of a smaller area of the overall kind of compute landscape. And the other thing is, it also just sort of leads to additional recency bias, because a lot of the computation needed on that is the stuff that is happening right now.
So yeah, great. So, yeah, I remember, I think it was Postgres 11 or 12 when they did JSON as a data type. There was the joke going around that they implemented Mongo as a feature. Sure, yeah. But yeah, so do you think that some of the velocity then is just addressed by the tooling and the services that are offered today? You have things like Kafka. You've got, you could point just the largest fire hose possible at S3 and dump it in there, and so that's just mitigated by these services, and therefore it's less of a concern.
Yeah, I think so. But I do think it's still an interesting area. And because if you do need to process the data as fast as it's coming in, and react to it as fast as it's coming in, which I think is important, you may actually have to scale out, because you just don't have any options.
Anything, Aditya, you'd like to add on that?
Yeah, I think to Jordan's point about being able to filter and kind of subsample or summarize or extract the high value nuggets as the data is being generated, and then landing those in a data warehouse. I think that's pretty difficult in my experience, because you often don't have foresight into what you're going to be doing with your data, right? And this is why you have the so-called whatever lake house paradigm emerging as something that people are doing, right? Because you store whatever data you're generating, you don't know what you're going to be using it for, so you can't really kind of get rid of most of it or summarize it or filter it, and therefore you kind of have to store all of it. And then depending on the query, you look at some of it or all of it, and so on. So I think the volume and velocity problem, what I'm seeing right now is people are basically saying, hey, I can't really deal with either of those at the moment, so I'm just going to store it. Storage is relatively cheap, and then figure out how to extract, transform it over time, right? So that's what I'm seeing emerge as a paradigm.
Well, yeah, the storage being cheap might depend on who you talk to, right? It seems like it's that first gigabyte's free, kid. Come on over here. Let's get it in. So we had a couple of questions that were sent in via video. So we had one from Andy Pavlo over at CMU. So let's go ahead and listen to that, and we'll have Jordan respond first to it.
Hey, this is Andy Pavlo from Carnegie Mellon University, AutoTune and Off-Prohibition Productions. My question is, do we think big data systems are unnecessary at this point because they're economically infeasible? The vendors charge too much, and people are just overspending on them? Or do we think we've just got to the point where single node systems are fast enough and you don't need large scale out massively parallel systems? Thanks. See ya.
So it's good question. I think the systems that we have that are scale out certainly are expensive. In theory, they're expensive because they're providing value commensurate with the cost. But I do think that it's that, they're not necessary. And when you don't have and when you scale up rather than scale out, your systems are so much less complex. Every programmer wants to implement Paxos or their own version of Paxos. But if you're not, if you don't, if you're just scaling up, you really don't need that. You don't need to build Shuffle. You don't need to build, there's just a lot of things that, your life gets easier. And so I think you can move faster and you can focus on, the things that actually matter rather than sort of the complexities of dealing with a scale out system. So I think that we can build more interesting systems if we scale up rather than scale out.
Anything, Aditya, you want to add or counter on that?
Yeah. So I think again, I'd like to go back to my analogy of this being just another instance of the cloud, right? Do you, as an organization, provision a fixed set of resources upfront, or do you flexibly scale up and down, right? And if you say, hey, I'm going to be provisioning a bunch of beefy servers, give one to each of my business analysts, and then let them operate on as much data as they can comfortably analyze in their beefy server. Soon you're going to run into management issues because you're going to have to deal with these very issues that Jordan mentioned of, you now have a job that can't be handled in a single beefy server. So you now have to implement Shuffle across all of these servers to get something done, right? And so wouldn't you rather just hand it off to someone who does it for you, flexibly scales up and down for you? So for a lot of organizations, that decision would be, yes, let's have someone else flexibly scale up and down rather than me managing these servers and provisioning for it. The other cost argument, which may change in the future, I agree, is that these beefy servers that you might want to buy in-house or reserve for your data analysts or business analysts or data scientists are still extremely expensive. So you're in fact, in many cases, the ability to flexibly scale up and down might actually be a lot cheaper than saying, hey, I'm going to get one beefy server for each of my business analysts.
So if I could just address that, quickly,
Totally.
The amount of hardware that's in a Snowflake XL is, I think, 128 cores. There's an i4i instance in AWS that I think is $11 an hour, and Snowflake charges roughly $48 an hour. So if you consider there's sort of the SaaS markup on top of that, it's not incredibly expensive to be able to run that yourself. And that's, huge. It's also a terabyte of RAM, pretty, there's not a lot of workloads that you can't run on a Snowflake XL. I think it's about $500,000 a year, almost $400K a year for that. So, and I think the other thing is, just as Moore's law keeps going up, okay, in another 2 years, that's going to double. Another 2 years, that's going to double. Another 2 years, you'll be able to get equivalent of a 2XL, and then 2 more years, it'll be a 3XL. And so, the amount of workloads that require more than that, I think, are going to be diminishing.
And so, as a comment on one thing you said, I was curious both your thoughts on this push for repatriation back from the cloud into on-prem. Is that something that you both believe, or you think it's it's not going to be worth it for most organizations to have to manage that on their own? Is the cost savings going to be worth it? It looks like we got in a question up here. Cloud computing in general is being proven as something valuable just for a small number of companies. DHH and 30. Yeah, so 37 Signals on this repatriation thing, right? They had that blog post, I think, talking about how they saved $5 or $8 million. So, Jordan, what are your thoughts on that?
So I think if you are repatriating data or working off your own servers, having fewer servers, the kind of servers that you buy these days off the rack are probably going to be, at least 64 cores, and you can shove a whole bunch of RAM in it. And so those are going to, probably meet most workloads that you need. Because I think you don't have to necessarily buy the big iron machines. The tricky part then comes in is making sure you have separation of storage and compute, but there are, off the shelf like MinIO and Ceph and Cohesity and kind of ways you can build that in yourself. But I think if you want to take advantage, I think even big data or medium data, building separation of storage and compute and making sure you have that is going to be critical to sort of having a robust system.
Yeah, that I agree with. I think it is being able to be flexible, even if you are managing your own servers, is going to be key. The other thing I won't comment on pricing because I wouldn't be able to check those numbers. But what I have seen is like the cloud data warehouses are getting increasingly, in my experience, commoditized and cheap. I think they have an incentive to drive down prices, just like these servers are getting cheaper to buy and provision. So like costs are going down on those fronts as well. So the markups are going down and costs are going down. People are sensitive to the fact that there is a perception of these cloud data warehouses being expensive. And so, yeah, I think different organizations are going to have to make bets differently depending on their needs. And there would be organizations who have the data engineering talent to be able to provision a large number of machines and deal with the complexities that come with that. There'd be others who are like, I would rather have someone else deal with it for me. And I think the small data workloads are not going away anytime soon. I'd also like to add, there's still going to be a lot of experimentation that's still happening in your laptop or on medium-sized machines, with the understanding that that's not going to be everything. And a lot of the important workloads are still going to need to look at a lot of the data.
Okay, so while we're on that, there's a question I wanted to get to, which was kind of like, how do you reconcile small and large systems with a unified interface, right? Like, so a lot of times people may want to just look at something recent, but Aditya's point is, no, you should be looking at the bigger picture, or maybe someone wants to develop on a smaller set and then go for it. And clearly there's a scale when the laptop's not going to hold, right? So start with Aditya, like how do you feel about kind of being able to quickly and easily migrate between the small and big data, we'll just use those terms for right now, as an interface?
So that's kind of like, that is, as far as softball questions, it's as softball as they come for me, at least personally, because of what we are doing at Ponder. Ponder's kind of like name of the game, or the motto is you should be using the same interface to operate on data at all scales, right? Use pandas the way you are using it on your laptop, on your tiny data set. Be able to use it the exact same way, even if the data is resident on a cloud data warehouse or somewhere else, right? In a S3 bucket. So that's the goal. And so I think there is a definite possibility that we can get there for all different forms of query languages and libraries, where users use the libraries the way they expect to, in a small in the way they would do it in a laptop, and preserve that user experience as it ends up going to a larger data set on a data warehouse, right? Why should the users have to worry about that? This should be something that should be happening transparently to them.
Jordan?
Likewise, it's also a softball question for me, because that's also one of the premises of MotherDuck, and what we're trying to build is basically saying you start with DuckDB on your laptop and then you extend into the cloud, and you don't have to make any changes. The fact that we're a single node system and a scale up system is really an implementation detail. It could be a scale out system, under the covers, and we might end up having to do scale out. The jury's still out on that one, but in which case I will retract my blog post. But we have an internal bet about whether we're going to have to do that. I'm taking the no. Other people are taking the yes. But yeah, I think that's there. There's a premise. There is obviously still a scale beyond which you need to scale out. But I just and there are kind of many organizations are going to have some of these workloads where you have to do this kind of thing, but there is still Spark, there is still systems that can handle that. And I guess the other thing is that there's always this performance versus scale out trade-off. And if you're willing to take a little longer, you can do anything on one node.
Great. So there's been a few questions coming in the chat that's kind of asking about what is your perspective on the role of real-time systems or real-time analytics, and kind of how do you see the future of streaming analytics? Like if you had to kind of squint and guess, like what percentage of analytics or valuable analytics do you think today are from streaming versus where they'll be potentially in 5 years from now? So how do you see? There's a question on the screen. So Jordan, you want to go ahead and start off with that?
Yeah, first of all, like I'm a huge streaming nerd. I think streaming systems are amazing. I think that's a more natural way of actually performing computation, even though it requires you to think a little bit differently about it. And in Google, we used to do a bunch of batch computations, and we switched a bunch of them over to sort of streaming computations. And they just worked better. They were more maintainable. They were more scalable. You could, when something breaks, you find out in 10 seconds rather than 2 days later when the map reduces stop working. And so I think streaming analytics is a great way of solving problems. It is, there are some tricky things, and I think there are some people that are trying to sort of tame some of that trickiness. In BigQuery, we were very into sort of streaming and making streaming possible, and reconciling state, I think, was one of the most hard problems. Late arriving data is also another hard problems. That said, I think it's always been 2 years away, and I don't know that we're any closer. Now that we've been 2 years away for 10 years, so I would love to see it be more common, but I wouldn't at this point. I wouldn't bet on it.
Yeah, I mean, I work with Mike Franklin, and he's been saying they've been working on this since the early 2000s, right? So it's been a couple of years away for a long time in his belief. But Aditya, you want to follow up on that?
Yeah, I'm less bullish on streaming systems. I think in particular, I think it's going to end up being more of a niche analytics use case, specifically targeted towards observability and things like that, rather than anything related to true insight generation, business intelligence, or machine learning and data science. So that's where I see the vast majority of analytics going to be at. And there's going to be a few niche use cases around observability and reacting to events, but I think it's going to be niche.
Okay. So we had a question from Astasia Myers. So let's go ahead and go to that because I think it might be relevant to where we're at right now in the discussion.
Hi, I'm Astasia Myers from Quiet Capital. Thanks for fielding one of my questions. I thought Aditya did a great job highlighting that there is a difference between record-keeping data and operational data. He argues that operational data grows quickly and can be bigger. I see this in my portfolio companies with machine-generated data. So I'm wondering, Jordan, do you believe that your claim that big data is dead is applicable to operational data?
So it's certainly an interesting question, and I think to me it's really about the operational data. It can get quite large if you're looking at your clickstream logs, and there can be a lot of data coming in. But I would say also a lot of that data, that's the data that decays very rapidly in value over time, and so looking at what's going on right now, what's happening, are there alerts, are there problems that are happening? Maybe you look at what happened yesterday, but it's much more rare that you would want to go and you scan the last 60 days or 2 years worth of data. So I do think that even though operational data can get pretty big, I think the fact that you don't usually have to use massive time ranges is really kind of what saves you and allows you to process it in a a smaller scale system.
So then pushing back for you, Aditya, a little bit to balance out the softball. So if operational data is part of this, what you said, you're not bullish on streaming data and reports in this, but that to me seems like that would be the value of operational data, is be able to make real-time decisions or near real-time decisions, right? So if you're saying the value of operational data is more archival, do you think there's good examples of use cases that have demonstrated that success? And then a related question that came from Mike Franklin yesterday, I'll just pitch this in there, is that he's had some conversations with folks. They say when this data starts getting older and older, like Jordan said, there's a decay, but part of the decay actually comes from that the applications evolve or the users evolve. So it actually gets a lot harder to model that data to say what was the state of things 3 months ago versus the state of things today. So
totally. Yeah. So I think there is a certain type of operational data that is, again, like observability, streaming, just like what's happening right now, like is my server running hot kind of data, right? Like that's not the data that I would consider to be, that data has certain use cases and interest, but imagine, let me paint a different type of operational or sort of event sequence data that could be equally valuable. Let's say maybe even more valuable. So let's say a user, I think I gave this example earlier, a user is interacting on a website, clicked on a bunch of things, decided whether or not to make a purchase, right? Now, that event sequence of what the user did is incredibly valuable for someone trying to optimize whether what are the pain points for customers when they're navigating a website, where are they getting stuck, why is that not leading to an eventual purchase? And being able to not just identify those patterns, but also try to draw inferences and trends over time, and also maybe build models on, this type of person does this type of action. All of that is going to be really important and is only possible with this machine generated data, even if you have things like sensors and so the other forms of machine generated data include like things like sensors. And again, there's a question of how do you make sense of all of this data with machine learning models, and even if you want to, not all of it is just like summarized away and a bias towards recency. Often you want to look at data over time and draw on insights across all of it, as opposed to just on the most recent stuff. And again, I think what we've seen with the likes of the large language models is that more data helps, right? And yes, for certain types of questions, more recent data helps. And these may be some of the questions that streaming systems are tailored towards. But the more general data science and ML and AI use cases do require as much data. They're data hungry. They can use all the data as much data as they can. To the second question on data drift, I think a lot of these machine learning and AI systems can actually learn the drift, right? They can learn the pattern change over time, while still capturing the underlying phenomenon, right? So I think they understand that, okay, I don't know, people's likes and popularity and friend networks are growing over time. That could be a part of a feature, but they take that into account as they're building the models, right? So, or as you train a model.
Then, so for Jordan, there was a question from the chat from Michael Siegel that was saying, part of the promise, maybe it kind of aligns with what Aditya is saying, is that with big data, your models and your decisions get simpler because, you just have more data and you do things. But the articulation, if you're trying to do more complicated, you might need to do more complicated analysis or more complicated methods or models with smaller data. Do you have any thoughts on that? Or
yeah, but I think also like some the experience of the large language models is that there's not everybody's going to have to train these things, and having training some of these big models obviously has to be done on massive clusters and with specialized hardware, but I think for most people are not going to need to have access to those things. I think Aditya's answer about being, there are some times when you do want to have to do some sort of deeper computation that's not just a simple sort of scan, filter, aggregate, and something that resists summarization over your data, and use more and a longer time window of data. Just the one thing that I would caution about from that is the longer back you go in your data, the more dangerous it gets to draw inferences directly from it based on how the data is being collected today, because schemas migrate over time. The meaning of something migrates over time. There were like data collection bugs or something, something screwed up in the system that only happened over like December in like 2017, and those kinds of things can sort of be these sort of silently skew the inferences you're making about the data. But the point is still valid. There are certainly use cases for broader computation and deeper computation over larger sizes of data.
So if someone came to you and they were kind of describing, what they want to do, how would you identify the difference between a big data problem and a problem with big data? Knowing which is the right case to go. Should I stay small? Should I go big? Do you have thoughts as to how somebody could get that insight or that knowledge? Or is this just something gained with pure experience and understanding?
Well, my philosophy is start with the simple thing until you've demonstrated that you can't do the simple thing. And so, yeah, give it a try. And if you can't scale it up, then scale it out.
Did anything to add on that, or is it?
I think that's in general a good rule of thumb.
Okay, so Aditya, Raul Castro Fernandez asked a question about, outside of operational data, do you find that there's other domains where the rate of data is really outstripping or outpacing the growth in compute and memory density? Or do you think it's really limited to kind of sensors, automated devices, and operational data?
So I think, okay, so there is two aspects here, right? Like one is the rate of data growth and the other is the compute needs, right? So one could argue that even if what you're operating on is medium-sized data sets, there could be situations where you want to provision a large amount of resources to be able to process that medium data set in a very, very small amount of time because it's a really urgent need. So I think simply saying, hey, okay, like the data dictates the compute needs, again, is painting in very broad brush strokes, because I think the timeliness of the need and the size of the workload are both important axes to be considering. And so depending on how timely the need is and how much data you're operating on, you should ideally have the flexibility to provision the set of resources that you want. And like I mentioned with the website example, like pretty much every industry would have sort of instrumentation of whatever people are interacting with, be it a website. I mean, if you think about healthcare, finance, retail, all of these scenarios, there's lots of data coming in, right? It's not a bespoke IoT sort of situation. The IoT itself is generating zettabytes of yottabytes of data, sure, but like even very quote unquote important verticals with lots of data or with lots of that rely on data a lot have this operational data problem, like finance and retail and healthcare, automotive, hardware, etc.
Great. So this probably for both of you, but maybe more Jordan is, Jordan, you partly articulated that, look, keeping this old data as a liability, there's potentially like the data quality degrades, there's the cost associated with the storage, there's even potential liability, security risks or whatever. But you're not saying that there's still no value in it, but it might just need a closer eye at understanding what is that data value to keep or how to keep it. Like maybe it is some kind of materialized aggregates or a model based on that data. So do you think there's good processes in place for people to kind of help sniff through historical data and see what is the right data to keep, or is it just kind of a green field right now?
Yeah, I don't know that there are great ways. I think one is, I think if you have a data lake, that can sometimes lead to sort of sloppy data management practices. That I think using a data warehouse and sort of proper data, like schema on read is sort of lovely for, hacking something and getting it together quickly and being able to make things continue to evolve. But it's really bad from a governance perspective, like, because you don't know what you have, and if you don't know what you have, then you don't know what you're not supposed to have, and then don't know who's doing what with, and how. And so I think, kind of using kind of more rigorous, either lake house or data warehouse kind of storage management, data cataloging, governance, and using that to understand what you have. And like somebody was talking the other day about they have a bunch of data sitting on S3 that they know no one has used in like 6 years, but they're terrified to delete it. And like that's a bad situation to get into. And I think the only way to, like, sometimes you just have to rip off the Band-Aid, and sometimes it's just sort of like, if I throw out all those clothes in my closet that I haven't worn in over a year, I always think, well, what if I need that for a costume, or what if I need that for something else? And it's like, you're probably not actually gonna need it, and you probably are that you're going to get less value out of it than you think by keeping it around. But I don't know that there's an easy answer to the problem.
Yeah, when Aditya and I were postdocs together at MIT, we had some interesting conversations with a group with, they had hard storage limits, right? So they had to get rid of data, and they just gave this nice analogy of the toothpaste, the fact, the tube, you kind of get, stingier and stingier, but they had to start deleting stuff. And their process for deleting was scary, because it was just emailing like, hey, anyone know what this data set is? Can we recreate it? Is it derived? Is it, so it was, it was an interesting exercise. Okay, so I think we're hitting about 45 minutes. I think we wanted to wrap up with you each trying to take the other person's perspective and kind of argue for the other side a bit. So with that, Aditya and Jordan, if you want to, switch gears and do that, I guess we should start with Aditya on this one and say what you think Jordan is right about.
Yeah, so I think definitely there is you should operate on the sizes of data sets that make sense for your workload, for your organization. I think thinking carefully about what makes sense for your organization and picking resources picking resources and processes wisely for that organization makes a lot of sense. So, for example, if there is a data set that you're never, ever, ever, ever going to look at, probably a good idea to delete it, right? Like, and if it makes sense to kind of throw out the cruft of your data. So, for example, your data is stored in an incredibly inefficient format. If you can get the same data set stored in a much more compact format while not losing any fidelity whatsoever, do that, right? Like, and so all of that is makes a lot of sense. And what else? So I think broadly thinking about every organization should make the trade-off between provisioning resources that are in-house versus resources in the cloud in a careful manner. In a lot of workloads, starting small and starting with your laptop is actually perfectly fine, and is a good practice, in fact, before you decide to run that $5,000 query that Jordan wrote about in his blog post. So I think start with what makes sense and then scale up as things go.
Great. It sounds like someone in your family was upset as you took that other perspective in the background. All right.
Sorry, I have a one-year-old.
No, it's just great timing to start and you kind of get into that mode of now I'm upset. They were good until you switched over. Jordan, you want to?
Yeah, so I think Aditya made a lot of good points. I think particularly there are some algorithms that and some data complexity cases where you're going to need access to a lot of data. Large language model training data. Things that have where you need all of the fields in a table. Like those are cases where scale out may still make sense. Scale up has some limitations still. it's difficult to get all of the power out of a large machine. Operating systems have some sort of like some high CPU limitations. Getting data on and off the machine is often a bottleneck. So like it's not, scaling up to giant machines isn't necessarily a panacea. And yeah, there are organizations that do have to deal with lots of data, and are going to have to do so for the foreseeable future.
Great. It's probably good to end where people can find out more about you or your organization. So Jordan, you want to tell people where they can find out more about you or more about MotherDuck?
Yeah, MotherDuck, MotherDuck.com. You can you can sign up for our mailing list. You can sign up for early access to our MotherDuck system if you want to see actually being able to use DuckDB in the cloud. I've got my third hat on, the DuckDB hat. Should be pretty easy.
Great. And Aditya?
I'll switch my hat as well. I don't have a third hat, unfortunately. Ponder.io is the place to go for Ponder. Ponder is building scalable data science libraries that run wherever your data sits. So if you'd like to try Pandas, which is the world's most popular data science library on literally any database or data warehouse, come talk to us. And we are doing private betas at the moment and likely to have a public beta very soon. And there's also an open source project behind it, which is called Modin, which you can go and check out. So Modin helps you run scalable pandas on Ray and Dask.
Great. Anything else from you two, or is that good?
No, thank you so much, Aaron, for hosting, and thanks to our people who wrote in with questions and our video questioners, Andy and Astasia.
Great. Yeah, thanks so much. This was a great time and an interesting discussion. So we hope everyone enjoyed it and learned something.
Totally. Thanks again, Aaron and Jordan.
Thanks. Bye.